Okay, hello everyone, and welcome to Handmade Hero, the show where we code a complete game live on Twitch. You know, one thing that I pretty much always say at the beginning of the stream is that we don't use any engines and we don't use any libraries, and that is true. And the reason that we do that is because, honestly, I always say that it's so we can see the entire, the entire pipeline of a game and all that sort of stuff. But honestly, there's a hidden part there too, which is just that I always get grumpy about the way other people do things. I think there's a control freak aspect of that as well, where it's not just that I think it's a good idea and educational to go through and do it entirely yourself at one point, but it's also that I would spend all my time complaining about how they chose to do something. You know what I mean? Do you ever get in that situation where you're using something and you're just you know what? This is just done totally wrong. I don't agree with any of this. And honestly, that's the experience I have most of the time I try to use that stuff. So I'm doing this one for educational purposes, but honestly, even if I wasn't, I still wouldn't be using an engine or libraries because, frankly, they're garbage. All right, so that said, I would like to go ahead and introduce to you Day 90. If you are trying to follow along at home and you've pre-ordered the game on handmadehero.org, you can download the source code from the link you got in your email. And what you want to do there is you want to unzip Day 89 source code because that is what we are starting with right now. So unzip that and you'll be able to follow along exactly with me. So let's take a look here at where we're at, what we have come to. And honestly, since it's kind of a little bit of a sleepy day today, I'm going to start off with something that I've been meaning to do for a long time. I'm just going to do it. It's complete busy work, but I want to do it anyway, which is I realized that I named these a little bit wrong compared to my code base that I normally use, and it drives me insane when I have to switch between them. So I put them as capital letters when we did it here, the XY and the XYZ and stuff, which is what I would normally do. However, if you have ever looked at HLSL or GLSL, the shading languages that you are required to write stuff in when you are using OpenGL, Direct3D, etc., they use lowercase accessors for their vectors. And I like to make my code so that it can compile both ways, so that you can have expressions that compile in a shader or in your code. And so what I did with my source code, the way that I write it, at my day job, basically, right, is I use the lowercase ones so that I don't have to do any translation between them, right? And so every time I switch between the Handmade Hero code at night and the code that I work on during the day, I always end up in this situation where I'm because I type the wrong things and it drives me bonkers. So I want to just kind of unify these two here so that I can stop having that painful process occur, basically. So that's it. That's all I really wanted to do was this. And so it's just annoying. I just have to kind of go through and change what people were accessing those by. So it's going to be a little bit of drudge work, but I really wanted to do it because every time I was and so I'm going to try and get us back to there before we get any further down the oops, that's not right. Before we go any further down the rat hole of using a different one. So this is going to take a while. I apologize. There's really nothing to describe. I'm literally just changing these from uppercase to lowercase, which is extremely boring, but that's just what you got to do sometimes. Oops. I wonder if I can do something like .x equals .x and have that be mostly right most of the time. Looks like it. So that's good. That looks good. So let's do that. That'll save us a bunch of time. Wasn't sure how likely that would be to work, but it looks like it does. So that's good. So let's do .y equals .y. There we go. That'll also, oops. That'll also save us from making typos potentially, hopefully. If I just pay a little bit of attention here. kind of crazy when you think about how much code you end up writing. We look through here and, 90 hours of code, I guess we've done. Well, maybe a little bit more than that. But 90 hours of code, and there's just so much stuff in here. Even though we're just, we're only maybe a sixth of the way through working on this stuff. Man, my head keeps obscuring that last replacement. All right, so that's one file down. So .xy becomes .xy as well. There we go. And let's see, .z, .y. All right. Okay, next file, .x becomes .x. Let's see if that's pretty good. And .y comes .y. It's one of those things where I do feel like I kind of have to watch each individual one, even though probably I don't have to. Yeah, you never do know. So .r is .r. I wonder if I can just do a thing where I won't do that. I was going to say, I wonder if I could do a thing that'll automatically do all of them for me. Emacs has ways of doing that, but I don't have enough Emacs foo to bust that out. All right, let's see. And B's. Yeah. And A's. All right. Let's see how we're doing. Those out of there. All right, and .z as well. Yeah. Well, that was a mistake. Oh, it's a sleepy day here. Yeah, I did not get much sleep last night, and then, I was doing a bunch of coding all day long, and then it's like, I think my brain might just be tired. My brain might just be a little bit tired. Sometimes it happens. Let's see, .z. There we go. All right. I liked it better in the old days when it didn't do this C declaration of thing, because jumping like that makes it hard to just quickly go through where all the errors are. And I don't know if you can turn that off. I've never looked. I should. But just kind of spontaneously turned on, and I don't know how you get rid of it. All right, so let's do .x. Yeah. A lot of those. All right. And .y to .y. All right. Like so. And last one, .z to .z. Okay. Last file, I think. This is the big one right here, people. Then we'll see if I made any critical replacement errors. .x. There we go. And change those. Okay. Oops. .y to .y. There we go. And .z to .z. All right. What do you think? Do you think it worked? Let's find out. Okay. Yay! Looks pretty good. Nothing particularly suspicious going on. So we'll call it good. All right. Okay, so now we can get started with other things. I really wanted to do that. I kept being like, you know what, I gotta do that sometime. And since, on a low energy day, you kind of want to go like, okay, what can I do that's not going to take a huge amount of mental energy? Something that like needs to get done, that's just kind of that sort of thing. All right, so let's take a look here. We were working on our render group structure when we last were handmade heroing. And we sort of introduced this notion of multiple things, like we had the rectangles and the bitmaps and the clears. We never implemented clear, though. And so what I want to do is I want to go ahead and implement clear. So I'm going to take the place where we were actually calling before we draw a rectangle to clear the screen, right? Like this is that, that rectangle clear call, right there. So what I want to do is I want to turn that into an actual clear operation. So I want to do like a render group clear where I just say, okay, you know what, clear the screen, clear it to this color right here. That's what I want you to clear it to, RGBA, and then we'll make it so that that actually does that clear operation. So in here, when we actually get one of these clears, what we're going to do is do the sort of the draw rectangle call that we were doing before, because we don't really need to implement an actual clear yet, and we'll actually make sure that it does exactly what we wanted to do. Now, we don't actually pack A in here at all. A has to be 0 for now. So what I'm going to do is I'm going to actually go ahead and make it so that there is an A for the draw rectangle call in terms of what you actually want to pack in there. It just defaults to 1, let's say. But that way, if you want to, you can clear the buffer to have an A in it, even though that's not going to actually do any alpha blending, if that makes sense. So I think I'll just allow it to do that like so. You know what I'm saying? So it'll produce that packed color like that. So if I do that, then what I should be able to do is just pass that as a v4, right? That v4 from the clear call, so this entry right here, right, will have that color that we passed. So this will just be color R. Ooh, I can do it in lowercase now. That's very good. So we'll do RGB and A there. So that way we can set the clear. And when we do that clear, when we do the actual call, we now have to, you know, anything that we want to do render-wise has to kind of go through that buffer push, right? And so when we have this here, we're going to make this be inline void clear, like so. And it's really just going to do the exact same thing that, you know, everything else so far has been doing. It's going to push on one of these render elements that's the actual clear, right? And excuse me. And then it's going to set whatever values are specific to that thing, right? So this, in this case, we've just got a color, and this is what we pass here. And so that's really, I think, all we'll need to do for a clear. I don't think there's anything else that would be particularly relevant, at least not yet. So up here, we now just need something for that. It looks like we've already got it, so that's good. So we'll put in color there, which is a little bit different from how we have it set up. We'll take a look and make sure that that's all kind of kosher. We need the buffer to be changed to whatever the output target is, right? So that's what that is, and that's good. And then we, need to change it here as well, so to get the width and height of that buffer we want to clear. So once we've done that, we can now sort of lean on that clear call, and that doesn't really do that much compared to what we would have been doing in software, but in hardware, and probably eventually in software as well, we'll be able to do a faster operation there than drawing something. We'll be able to, most renderers and all hardware has an accelerated way of clearing things, because it knows that it's doing this sort of block operation. Instead of having to figure out where something is, it knows it can just do the whole active buffer at once, right? So we should now have that working. Of course, we can't really tell, but we can still see the purple flashes, so we can kind of assume it's working, although it's not a super great test. What we could do is, of course, stop drawing our ground patches, for example, and make sure that we're actually seeing something back there. So what I can do is I can go in here and say, all right, this thing here that goes through and draws these ground buffers, I could just make that stop, right? I think that would probably do it. Why do you do this to me? Why? Constitutional impress. Why is that even in our build? That's going away. I hate that warning. It's like, why are you even telling me that? I know whether I wanted it to be constant or not. It's not your job. So that's clearly clearing it to that beautiful, beautiful pink. It's really, when people say their favorite color is pink, that's the pink they're thinking of, is that pink right there. It's this sort of lush magenta. Favorite of artists everywhere. I think it was Leonardo da Vinci who said that, if he could, that the perfect painting would be nothing but a canvas of pure magenta. He also listed the HTML pound color for it, FF00FF. So what you want to do now, or rather what I want to do now, is go, okay, what's the final set of things that we haven't moved over into the renderer? And I think out of those, I remember there was an outline call as well, and that's not going through our renderer yet. Just trying to think if there's anything else that ever gets drawn, right? That we don't do. And you know what else here? This is interesting. So the other thing that we haven't addressed is the ground chunk. That's calling the bitmap routines directly, not the renderer. And so I think we will more than likely want to port that as well. So maybe that's what we'll do next as well. But I'm pretty sure we've still got the outline calls, which have not. So this, yeah, these two guys right here. So push rect outline and draw rectangle outline. So both of those, I think maybe we want to make those happen. We want to put those into the render as more of a, as more of a specific concept, basically. So I don't really remember how this was working. I feel like you don't see these. I feel like these don't show up normally anyway, because they were behind the ground chunks. So one thing I could do is say, okay, like after this filling happens here, oh no, I guess they would show up after, because these get pushed on first. All right, so that's fine. So when those get pushed, then what I would do here is I would say I want to be able to have the rectangle outline get pushed on as well. And one thing that I'm not sure about yet, I don't think we probably want this, but the phrase push doesn't really probably need to be on here anymore either, right? We can probably get rid of that nomenclature in a second, but I'll leave it for now. So we'll just call this push rect outline for now, and we will go ahead and port it to what needs to happen for us to actually draw here. All right. So if we want to push the rect outline here, let's take a look at how this is being done. So screen P, that looks like it's actually something in screen space. Do we actually care about any of this though? How is this stuff working? That's strictly something that's being used for rendering, right? So let's move that down here so we can see what sort of stuff we're using for rendering. Similarly, screen dim is also only used for rendering. So really, that's those two. What about rel P? Rel P is actually used, okay. So really this is what we're doing for rendering here. And we're differencing off the center of the screen, which is really not necessary because the renderer will do that part for us. And the meters to pixels conversion it will do for us as well. So I think most of this stuff, we can actually just use the standard things that were happening kind of automatically to make most of this stuff happen. So I think we can get rid of most of this. We can just say, okay, you know what, the V2 for this is actually just going to be rel px, rel py. So it's just going to be that. That's where the rect outline starts, I guess. And to be honest, I guess I don't know. Yeah, it looks like that's the center, right, of it. So that's fine. And if that's the center, I got to see. So this does min and max is what it was doing before, right? Right. It was doing minus the screen dim plus the screen dim, and here it just does the dim. So we can just do without doing meters to pixels. We can just do that world chunk dim in meters basically. So now we know that as well. So I think we more or less could just do something like this and kind of be done with it entirely, if that makes sense. Not have to do any of that fussing there. Don't quote me on that. We'll see. Is it not push rect outline? It's push rect outline, right? Did I miss something? Oh, it doesn't take 4 arguments. That's probably true. It doesn't take 4 arguments. That is because we need to put in an offset Z, like so. Dim and color. Color is a V4. So let's make sure it's a V4. And this needs the render group. Render group. All right. So let's see if that gets us any outlines. Oh my. I guess we forgot to update our push rectangle call. Yeah, these are still push piece calls. We want these to be push rect calls, not push piece calls. So let's go ahead and change those, because I guess we haven't ever called push rect outline since we did the port to the renderer, so it's still a bit janky. What does it need? Let's see. Push rect takes the group, the offset Z, the dimension. So it doesn't take the alignment, that goes away. Takes the dimension, and that looks like it, I think. There we go. So there's our tiles. Always good to be able to see those again. Let's also add back in the other thing that was, I think we had one here that would show the spaces that were defined. So let's make sure we can push those on as well. I assume that we can. I don't actually know why we wouldn't be able to, because I don't think we changed anything. There they are. So those are just empty spaces that were defined in the game, so that's good. All right, so everything seems like it's flowing through properly now. So I think that may be all of the calls to draw anything that we had outside of fill ground chunk, right? Do we see any others? No, we don't. So I think that's probably all we really need to do for that. Now, one thing we do want to do, like I said here, is I think we want everything going to the renderer. So I think we want fill ground chunk to probably be able to go through the renderer relatively easily. And that means it's going to need access to some kind of renderer that it can use. So what I'm going to do is I'm going to pass it the renderer as well, and allow it to do its own kind of rendering for now. We'll see what happens with that, but that seems like it should be pretty straightforward. So what I want to do is say, all right, that kind of happens up here where we do these ground buffers. You can kind of see where we right here we do them. The render group is already something that we have at the time. So what we can do probably pretty easily is we could probably have the ground buffers just work directly through sort of that, we could probably have them work directly through that render group before we really get started. Now, we'll probably want to, like I said, do these on a separate thread eventually, so they would be using a different render group, but for now, we really don't need to use a separate render group. Although, you know, now that I think about it, I guess we just could. That doesn't really even matter. So, you know, we could just do this, right? Ground render group. It's so easy to do, right? We could do something like this where we just say, all right, let's do that render group right here where we have like ground memory, right? And then we'll just release it when we're done. So we'll just do end temporary memory down here. Right before we do end temporary memory, ground memory, like so. I think that would just work, right? I don't think there's really anything fancy that has to go on there. And so then what we could do is say, let's just go ahead and sort of let this fill ground chunk stuff. Let's let that actually use. Let's let that actually use our render group. Now I don't actually know. I gotta go make sure that the ground chunk will actually work. Like I don't actually think there's anything special that it needs, right? It wasn't doing anything. Yeah, it doesn't do anything that we can't do through the renderer. It's just drawing some bitmaps. So yeah, I think we can literally just go ahead and do it. So when we do fill ground chunk, what we do is we go ahead and take that render group, right? And in fact, I suppose we could even, instead of doing it there, we could even just do it in here, right? We could just do it right there. So that whenever we want to refill one of these ground chunks, we just do it like this. And then it sort of can just build its little queue. And that would also let us leverage the sorting that we're going to do, which will be kind of cool because then we don't have to make two separate loops. Like we don't need two separate loops here like we have. We could just use one push call and have them both get sorted. So that's kind of nice. So let's go ahead and see if we can make that happen as well. That seems like a good idea. All right, so if we make this happen with the render group, oops, we're going to need that transient arena, but we have it, so that's fine. And it doesn't look like there's anything else in particular fancy that has to happen. So it would literally just be making sure that we, at the end of it, render everything out to whatever that target buffer is. So if this is the buffer that we're trying to target, we would just make sure that we sort of push everything out at the very end, right? So if we do this now, we should presumably get, well, we'll get nothing. Although we could say that we could put a clear in here and verify that things were actually happening. Like if I say clear, render group, v4, and put in maybe a nice yellow, a nice tasteful yellow, I should say. Let's go ahead and do that. We should see all our ground chunks be yellow now, like so. And the reason for that is because, again, this is still just calling the draw bitmap directly. So all of these draw bitmap calls are actually happening on the destination buffer immediately when they get called. But then at the end, we say render group to output, and it starts interpreting the commands. The only command it has is clear, so it goes and clears the buffer, right? But I just wanted to do that to make sure that it was actually going through the pipeline properly, and it looks like it is. So then when we get here, we can just change this to a push bitmap call, right? And then we just have to change it to use that renderer syntax, okay? So when we do that, what we want to do here is say, oops, let's see, push bitmap. What we want to do here is just pass the same stuff, the stamp, right? The offset is just that pxpy. I believe we have some stuff here that makes this a little bit trickier. This is being done in pixels at the moment. And so this is kind of interesting. This may be a little bit of an impetus for us, though, to go in and support pixel positioning, which isn't particularly hard for us to do. And so maybe now would be a good time for us to start thinking about that. So how would we do that? Well, we can actually cheese it right now, basically, in a pretty simple way. Like, let's say we just want this to be pixels. So we want to push that bitmap on, and previously we're calling this, right? And we just want to literally have it, do exactly that draw. So we don't want anything other than that. We don't want a z offset, right? Where's that bitmap call? There we go. We don't have any alignment or anything that we needed to do. We've already done that, although we could start passing that along. And so we're just going to let it do its thing. Now, if I do that, right, if I change our two push bitmap calls to do that exact thing, then the problem is now those, the problem is I obviously have not finished what I was doing. What is the problem to loaded bitmap to render group? Oh, yeah, sorry. It's render group. There we go. If I do that now, P, right, is in pixels, but the renderer only works on things in meters, and it always converts them up to meters to pixels, right? So if I do this, you can notice that, okay, so there is some splatting going on there, but it's not at all right, because only a couple things will still fall within the rectangle, because everything else will have been generated way outside where the actual rectangle we were trying to fill was. So as I say, is we can cheese that pretty easily, and it sort of sets us up for doing the next step that I wanted to take with cleaning up our renderer. And that is, there's a meters to pixels that's specified, right? And instead of specifying the actual meters to pixels, I can just specify nothing, right? I can just say, you know what, it's 1. Don't actually do any multiplication, just leave the values the way they were. And if I do that, then the stuff is actually in pixels, right? Because if I pass in pixels values and I multiply them by 1.0, I get pixel values, right? And so, hey, that's an easy way to change the scale that everything is operating in the renderer, right? And you can kind of see this a little more concisely, right? If I open up the code here and I just kind of edit it while we watch. Let me go ahead and kind of pull that out there. So if I edit this code while we watch, we can kind of see Let me move over here so we have a little more space to see it. This is basically, it's just a scale, right? You can see that if I scale, as that number gets higher, then the separation between these things gets bigger because the placement of each of these elements is getting multiplied by a higher and higher value. Similarly, I can sort of condense them down, right, into something that's very smush face, or not, as the case may be. Oh, there it goes. I don't know why that wasn't reloading. Let's try that again. Oh, it's just taking a long time when I do 0.1 for reasons that are not immediately clear to me. But anyway, you can see, right? Oh, I know why. Because a lot more stuff falls within the actual rectangle when you do that. So anyway, you can kind of see what happens, right, with that scale value. And so all our meters to pixel value was something that was kind of taking a small number, which is meters, relative to the number of pixels on the screen, right? Because a meter in our world is pretty large here, and a pixel is pretty tiny. It's taking a small number and blowing it out to a larger one, but we can just not do that, right? And so what I want to kind of introduce with that, since we haven't ever formally really talked about this, now is probably a good time to talk about it. What I'd like to start talking about is just the concept of coordinate systems and of bases and that sort of stuff, because we want to start actually having a real notion of those in our renderer so that we can, do more powerful things with it. And so that we have less stuff that confuses us, like negating y and multiplying by this and all that stuff. It'd be nice, to sort of get things more towards something that's a little more reasonable. And so what I'd like to do is just go ahead and talk about that on the blackboard for a minute so that everyone kind of gets what the idea is. All right, so here we come with day 90. There is day 90. So what I want to describe now, and this will probably take the rest, I think, probably of the session. I think that'd be my suspicion, but because it's probably a fairly in-depth topic, but we'll do our best. So what I want to introduce here, and I think we kind of talked about it a little bit, but not in the context, not so much in the context of rendering. But what I want to talk about is that concept of a basis, right? Or another way to think about it is an axis, right? These are similar things. Because typically we see these a lot, like we'll draw things, right? Like this, and then we'll say like, oh, this is the x-axis, and this is the y-axis, right? And we don't think a huge amount about what they mean. If you haven't spent a lot of time doing graphics programming, you're not thinking about these much other than like, oh, they're just some lines on some graph paper, or there's some stuff on the screen that sort of is, one goes up, one goes to the side, or whatever, right? But these are actually fairly important to think about as first-class citizens, and it's important to sort of think about, what I would say is how we measure things, right? And the place where we talked about this before was with the dot product. And if you remember, I said that with the dot product, what you can do is you can measure a point along some unit vector. So if you have like a vector, right? I've got some vector v, and I know that v is unit length, right? It's a unit length vector. Then whatever the point is that I'm trying to measure p, if I take if I do the dot product of p dot v, right? That actually gives me how far along v I traveled to get to the place where perpendicularly, like a right angle, p would have been projected onto it, right? And so what that really is that's a thing that generates coordinates off of axes, right? If this was the x-axis, then I would be asking what p's coordinate was on the x-axis, right? If this was the y-axis, I'd be asking what its y-coordinate was, right? And so we talked about this. If you don't remember that, I highly recommend going back and watching the dot product episode. The dot product is incredibly important. But that's like how we measure things, okay? And axes are the basis of that. Axes tend to have, when we use them in games, they tend to have two properties, okay? The properties that they have are one, unit length, right? And the reason that they have unit length is because that allows you to use coordinates in a logical fashion, right? You can basically say, okay, I know that I can dot things onto these axes and I'll get a coordinate on it that is actually the distance I would move, in whatever space I'm in. It's the distance I would move along this axis to get to that perpendicular point, right? Whereas if the axis is scaled, right? So if the x-axis, sorry, I should say, if this v was not unit length, if it was, say, length 2, right? Then p transpose v, remember, length of p, length of v, cosine of the angle between them. That's the formula for the dot product, right? If this is scaled, so this was 2 or something, then this value is no longer allows us to do our sort of length of p times 1 cosine of theta, which is what produces this projection here, right? It produces this value. Again, cosine theta, there's our theta, right? So if this is an extra value in here, we're multiplying that coordinate by the length of v, which we don't want to do. It produces a result that's not very usable for us, right? So unit length tends to be 1, and orthogonal, or I should probably say, I'll say orthogonal. Sometimes it's hard because orthogonal, because that gets overloaded with orthonormal, which kind of wraps in the unit length part of things. But what orthogonal means in this case, what I'm trying to convey with it, is the fact that the basis vectors tend to be at right angles to each other, right? And the reason that they tend to be at right angles to each other is because of a property called linear independence. And this goes way back. This goes so far back in my math education when I was reading like Introduction to Linear Algebra. Independence. My handwriting's so bad I can't even tell where in the word I stopped. So this is something that pseudonym 73 will hopefully clean up for anyone in the chat, or maybe on the forums, or some other person who does math for a living. Because like I said, it's way back in my math education. But basically what linear independence means, for the purposes of our discussion, is that when we are talking about coordinate systems, the reason we like them to be at right angles to each other is because the coordinates along those axes do not interfere with each other, right? So if you think about it, let's say I've got 2 axis systems. One looks like this with a right angle between them, right? Here's my x, here's my y, okay? But then I introduce 2 other axis systems, and they look like this. They've got something in here, some theta, and theta is not equal to 90 degrees. It's some other angle, right? And so this, we'll call this like u and v or something. Now when I look at these axis systems, what you will notice is that if I want to locate a point, in this, you know what? Now that I'm thinking about it, this is really the wrong term. I should not have introduced that. Because linear independence, it's really just orthogonality. Because the thing I'm about to describe has nothing to do with linear independence. Linear independence is a thing where you have matrices, whether or not they end up collapsing on each other. So you know what? Forget I even said that. If you want to know what that is, do ask pseudonym 73 to explain it on the forums. Because I just realized I don't really even need to talk about that. So yeah, let's pretend I never said that for now. That'll come up some other time, maybe later. I'm really only talking about orthogonality here. And linear independence really isn't an issue because these would still create a linearly independent basis if you wanted to, if you made a matrix out of them, I'm pretty sure. But anyway, so ignore all that. My bad. Again, sometimes my explanation's not fabulous. Let's get back to the important part. So if I want to locate a point here, right, point P, versus a point here, what you can see about these 2 systems is essentially that when I map this P coordinate onto these 2 onto these 2 axes, you'll note that motion along the y-axis does not change the motion along the x-axis at all, right? So if I want to find P, I can literally I can consider the locations of it on the two axes completely independently of each other, right? I do not need to know where it is on one axis to think about where it is on the other. So basically I can do a dot product here and I can do a dot product here and I'm done. Those are the two coordinates that I'm talking about, and there's nothing else that needs to happen. But if you think about what happens here, it's quite a bit different actually, right? If I wanted to find P here, well, I could easily see where it was along V, right? It might be right there, okay? So that's pretty easy. And if I wanted to, I could also see where it was along U, right? There it is, right? That's where it is along U, perpendicularly speaking, right? But what you'll notice is when I go up along this axis, right? When I go up along the U axis, I'm actually also moving the point along V. Do you see what I mean? Because if I said that this was, let's say that this is 5 units up, right? Or something like that. That's 5 for some reason. Who knows why, it just is. If I went 5 units up here, I don't just get 5 units higher in space. I also get 5 units along, I also get some amount of that 5 units in V. And in fact, I get the amount that's proportional to that angle. That's that cosine again, right? So I actually move cosine theta, right, times however much that motion is in V. I move that along, along U, in V as well. And that just creates a much more complicated scenario that you constantly have to think through, right, whenever you're doing things. Whereas in this one, when they're orthogonal, you end up in a nice pure scenario where you can always consider each axis completely independently, and you don't have to worry about the interaction between the two. And so that's what the orthogonality gives you that you want. It just makes life a lot simpler. It's not that you couldn't do things in this system, because each point can still be uniquely located using this system, right? I can still say, oh, well, you know what? If I wanted to get here, what I would do is I'd first move up this far, right, along P, which is not the dot product of it on U. And then I would move this far along V, right? I can still get there just fine. And it's still unique. There is still no other way to produce P. So it's not like it creates some ambiguity about what the coordinates are. There's only one set of coordinates still. And that's why I said this was the wrong term to introduce, right? And in fact, I could probably, I'll try to save, maybe I'm only making things worse, but I'll try to save pseudonym 73 from having an aneurysm here by just briefly saying what this is, or at least what I think it is. And so then, maybe this is only going to make it worse for him to try and untangle it later. But, I'm a game programmer, I'm not a mathematician. But you can imagine coordinate systems where even that wasn't true. And that's where the linear independence things comes in that I was sort of saying I thought I was going to have to introduce, but I realized to talk about the thing I want to talk about, I didn't really have to. You could imagine making coordinate systems where there are multiple ways to describe, where a point actually is. So let's say I created a coordinate system that looked like this. So I have a 2D plane, and I'm using U, V, and S to say where a point is, right? And so if I have a point here, at some point, you will realize that because I have 3 vectors, and there's only really 2 degrees of freedom in a plane, right? I could get there via multiple paths. I can trade off between, say, the S and the V, how far I go on either one, and still get, I could go this far up S and then this far in U, or I could go this far in V and this far in U, right? Because these basis vectors, S, U, and V, they are not linearly independent. They collapse, how should I put this? They do not uniquely span this 2-dimensional plane that I'm talking about. They are redundant, right? And because of that redundance, it means that if I want to talk about a point P, I can't assign it a single unique coordinate and say anyone who ever wants to talk about this point in space, given this basis, has to use this value. There's many values I could assign to it. There's infinitely many, in fact, right? So that would just be crazy. And like I said, I don't really need to talk about that for talking about what I need to, but I'll just briefly mention it. And if you get into more linear algebra, right, what happens is you imagine matrices with these things in them, and it's whether or not that matrix ends up having, whether it's singular and stuff like this. You could there's linear algebra afoot here, right? But getting back to just the more intuitive stuff, you can see why these are important properties, right? For what we want to do, we want to have unit length. We want to have them be orthogonal, and you might grab a little bit from this and just say, and we want them to be minimal, right? In some sense, right? We want them to uniquely span the space, but no more. So if we have a 2D plane, we want two bases, right? We want x and y. We don't want some other basis jumping in here, making things more confusing for us. So we typically want, the same as the number of dimensions. We want them to be unit length. We want them to be orthogonal to each other. And the same thing happens in 3D. When we extend it out, here's our x, right? Here's our y, here's our z. When we extend it out, we want the exact same thing to be true. We want all of these guys to be unit length, right? Want them all to be unit length. We want them all to be orthogonal. So there's a right angle between each and every one of them. And that goes for every single pair, right? And you can imagine writing this in terms of that dot product again, because if you remember the dot product, I spoke about this before, cosine theta. Well, if theta is 90 degrees, right, what's the cosine of 90 degrees, right? Remember your circle. Here's the circle, right? This is our unit circle, right? And as we go around that unit circle, cosine is the x-coordinate, sine is the y-coordinate, right? So here's 90 degrees, right? Here's our 90 degrees right here. When we're here, what's our x-coordinate? It's 0, right? So cosine of 90 is 0, which means that the dot product, and if it's 0, everything else goes away, which means that the dot product of any two vectors whose angle between them is 90 degrees in space, the dot product is 0. So we can define this these requirements for our coordinate system similarly by saying we also know, not only do we know that all their lengths are 1, we also know that if you take any pair of them and you dot them together, you will get nothing, right? And that's what we like to see, right? That's what we want to see. So that's kind of how we define basis vectors, okay? Now, moving up from basis vectors, a lot of times, it depends how you want to describe a basis vector. I actually use it then to start talking about any sort of coordinate system like that I introduce, which may be stretching the term basis a little bit thin, but it's still, I think, probably technically correct. Because that's like what we would create for our actual screen coordinates, or our actual world space coordinates would be obeying this. But what we probably, and this part, we're probably never going to change. This is going to be true all the time. Very rarely are we going to do anything that messes with that. But this part right here, we may change, right? And so that's where basis vectors get a little more interesting. So when let's talk about how to represent things in base vectors, then we'll talk about that scale. Let's see how much time I got. I got 7 minutes. So what I want to say here is, these basis vectors are ways in which we can both measure things and encode things, right? So if I take a basis like the screen space basis, right, it's a way of encoding points. So I'm encoding points by saying I'm going to record where they are, right? I'm going to record where they are by what their measurement is along axes. So if I want to record P, I record P by saying what is its x position, what is its y position, right? I want to know what its measurement is. And with that measurement, I can reconstruct what it is. But the interesting thing about that is that process, right, can be made more explicit. And when you make that more explicit, you can do more powerful things with bases. So for example, we are used to using these relatively directly. We are used to saying, oh, okay, we just have some function, like you saw us with the pixels. We do something like, okay, we've got pixels, right? And we look at the pixels that were at like y times stride, plus x equals some value, right? Equals the color, right? You saw us doing a bunch of drawing things where we were doing this. This is how we were drawing things. Implicit in that is this understanding that this layout, this grid of pixels that we're outputting to the screen, implicit in that is that we move by rows when y changes, and we move by columns when x changes. We just baked that in there, and that's what x and y meant, right? But if we want to get to more powerful rendering, what we want to be able to do is we want to be able to rotate things. We want to be able to scale things, right? And so in order to do that, we want to start thinking about these bases more explicitly and thinking about screen space versus sort of object space or world space, all these sorts of things more explicitly. So we already have one of those, right? We already have one of them happening already. And that is meters to pixels, right? You saw this happen. This is a basis change. All right, we baked that in, but that's a basis change. What we were saying, literally that whole time, we never mentioned it because we haven't really gotten to the point where we want to dig into it, but now's the time. What we were saying there was, okay, we have, oh, and you know what? Negate y. Those are the two things. These are all basis changes. That's what they are. We were saying this is what our world x and our world y axes are, and we are describing points in world space, right? That is what we were doing. Maybe I should be a little more consistent there. X world, y world, right? There we go. X world. Oh wow, that's not X. Y world. X world. There we go. A little bit better. My handwriting's atrocious. Right? That's what we're doing. We're specifying these in world space. We were saying that one unit along X or one unit along Y or something was a meter, right? I think it's what we said. So these are in meters. One unit is a meter. That was its units. This is our world space basis. That's what it was, and everything's described in it. But when we render, this is completely unrelated to how we were rendering, right? This is a totally different basis. What we did is we changed the basis. We changed the basis to screen space. And first of all, I should draw that the other way, because what we actually did was negate y, right? So in our screen space basis, you can actually think of y as going down, because that was what its direction was. It was left-handed, right? So here's our y in screen space, and here's our x in screen space, right? So we needed to change the basis of this thing, if that makes sense. And it's hard to say, I should clarify a few things, but I'll get to it when we get to it. So when we wanted these, when we wanted to actually draw things, we did two things. First of all, one unit is now like, is this high, and it's a pixel, right? So that's one on these. And we have different pixels, right? And so to go from this basis to this basis, right, we had to basically do these two operations. We had to negate the direction that y went, always, and we had to change the scale of our coordinates because they were much larger. The coordinates would become much larger when we went to pixels, when we were going for meters. And so what we were effectively doing is we were applying a scale, right? We were applying a scale to our bases. We were scaling, and the scaling that we were using is we were using meters to pixels, whatever that was. We'll just call that, I guess, m for now. We were using the scale m on the x-axis and negative m on the y-axis, right? Because we were flipping that y-coordinate, right? It was flipping it around because that's just how we wanted our stuff to go. We wanted it so that if it was moving upwards in sort of the notion of space, upwards here goes down the y-axis. It gets less, whereas upwards here it gets greater, right? And so you can think about this as taking those coordinates, right? In fact, I can sort of, let me take a few more minutes here and just show you one more thing, because this is something we probably want to pick up on tomorrow. But if you take a look at this, right, what happens here is, how would we have known, like how could we describe what we were doing? We did it by intuition. We negated y because we needed things to go the right direction in screen space, and we had meters to pixels because we knew that's how big we wanted stuff to be. But how would we actually talk about what really happened there, right? And the answer is, you can actually do what I was saying before in terms of measuring things. I can actually measure this basis in this space, right, if I want to, right? That's something that I could do. And I can also measure this basis in this space, right? I can figure out where these things were, right? And so that is almost exactly, that's really exactly what we were sort of doing. You'd have to, I'm trying to think of a good way to say this. Let's pretend we had some third universal basis, right? There's some third universal basis that's magical. We don't know exactly what it is, right? But we have some universal basis, the magical God basis, right? So this is X universal, and this is Y universal, okay? And we imagine that we had both of these bases described in the same space, right? Well, what would it look like? Well, our pixel basis, right, would be here, let's say, right? Here's our pixel basis. We're just making this up. Here's our pixel basis, right? So this is going to be, what did we call it? Did we call it screen? Yeah, that's what we called it. So here's our screen axis, and here's our screen y-axis, right? And you know, if I wanted to pick the unit on them, let's say it's there, right? So that's 1 along those axes. In fact, I could just draw them that way to begin with. That's probably the easier thing to do. Let's just draw it so that it's unit length. So that's 1 unit in that direction, right? So there's X screen, there's Y screen. So that's my screen space basis. Now I've got this other basis, right? That's this sort of world space. And world space is not only totally different size, it's also somewhere else entirely, and the y-axis goes in a different direction, right? All of that stuff is true. So I've got something that looks like this. There's my world space basis. Here's my X world space. Here's my Y world space, right? So these are my 2 bases. This is what I'm drawing to the screen, how I'm figuring out where the pixels are. This is my world space. And this is just some synthetic axis that's some universal in which they are both, which it is possible to represent both of them, right? So if I now want to ask the question, how do I move a point from world space into screen space, right? How do I know what this value is in this basis, right? I can actually do that somewhat directly, right? I can actually say what I want to have happen there. What I first would do is I would transform it into this other space, this universal space, right? I would first say, okay, I know where the origin of my world space is in this space, right? It's going to be, you know, the world space point, the world space origin, I don't know what you want to call this, world space origin, origin of the world in U, right? I know I start there. I know I go whatever the coordinates of this point are. Why do I keep mixing up my X and Y axes? That's crazy. I really, really want to call those X, and I do not know why, pun intended. Guess it's just that kind of sleepy day. All right. So here's my y-axis, y-axis, x-axis, x-axis. Try that again. Okay. Sorry. Back to the point. I can imagine starting here, going as far as its coordinate tells me, because remember this has a coordinate, right? A, B, or whatever, right? So I would just go A along this axis, and then I would go B along this axis, and I'd be there, right? And now I would want to know, well, where is it? You know, where is it in this coordinate system? So then what I want to do is measure where it is in this one, right? So the first step that I would do, if this was A and B, let's say that's really what that was, right? The full equation is I start at OW in this space, right? I then add A times whatever that x-axis is, plus b times whatever that y-axis is for the world space basis. And now I am at PW. That's where I am in this space, in the U space. This is the universal, in fact, I should say P universal, right? In the universal space, that's where I am. Now, if I want to measure that, right, I can just say, well, I know how to figure out where it is on one of these axes. It's just a dot product, right? That's all that is. So if I want to figure out what P is in S space, I could start by measuring it along these. I could do that with dot product, but this is at a different place. It's not coincident. The origin of that coordinate system, right, is not in the same place. So the first thing I have to do is make it relative to this coordinate. And I do that by subtracting wherever this guy is, again, in that U space, right? So what I would say is, okay, I've got that screen space origin, right? Origin, screen space. What I'd do first is I'd subtract that, right? So I'd say, okay, P of U minus that origin, that is the sort of the local version of that PW. But now I also need to know, what its measurement would be along these axes, right? And I can do that by taking that dot product, right? I can just say, oh, okay, I need to figure out where they are along this. I'm way too over time here. Yeah. What should I do? Kind of wanted to get to the end of this. Well, I'll give you a little preview of what we're going to do, and then we'll pick up on this diagram tomorrow, and then we'll go implement it in the render. Let's say that's what we're going to do. So, all right, pretend I didn't quite write this math yet. We'll write this math tomorrow, and we will go and implement it in the renderer. What I was going to say simply was just we need to measure it, and then we will figure out where it is in this other space. Once we have done that, we will be able to see that you really don't actually ever need this external coordinate system. You just need the relationship between these. It just, the math boils down to the relationship between the axes and their origins. So we end up just doing the relative corrections to move things. One is we translate the origin, right? So we add to the point whatever the difference in origin is, right? Or rather we subtract, depending on how you want to think of it. And then we change the scale, like we had to account for the difference in axis sizes. And then we have one more thing to do, which we haven't actually done yet because we haven't supported it at all, which is rotation, because these axes could be anywhere, right? And that's that dot product piece. And the same would be true here, right? So what we'll see is we'll see that collapse down, and we'll see that really what we were doing with negate y in meters to pixels, right, is just this operation. So if we want to, we can introduce a more powerful version of that supports the rotation and arbitrary scaling that we're going to want for the renderer. But I think if I went now, I'd be totally out of time. So maybe we'll pick up here tomorrow so that we can actually have plenty of time to discuss it. All right, so I will go to the Q&A for now. All right. So is that relatively, was that beginning to make sense if I had had another, let's say, 20 minutes to go through? Did you kind of see where I was going, even though we kind of got cut off before I could get there? Mr. Fourth Dimension, would you represent the origin of coordinate systems in a universal coordinate system? So basically what you don't actually have to ever represent it in a universal coordinate system. You just have to kind of introduce that so that you can think about them being in some space. But what we actually do in the game is we don't ever actually need that universal coordinate system, because what we think about is we just think about where the camera is relative to the origin of the world. So what we typically do in the game, right, and you've seen me do this a bunch, is we have some world space, right? So here's our world space, right? And there is a 0, 0. There's a 0, 0 in world space. It's like where we started making like that first room, right? Like here's the first room, that we made. I think that's how it lines up. I don't remember exactly where the actual world space is, but there's the world space, right? And what we do is we say, well, there's a camera, and the camera is here, and the screen is there, right? And the screen is its own space. Its origin is actually up here, right? Like that. And we never really explicitly form any kind of a notion of some universal coordinate system for these two things, right? We never really think of it that way. All we do is just go, oh, well, we know that if the camera is here and here's where that corner is, then to translate from world space, we have to just move things so that they're relative to that. So we subtract this point from everything to put everything as if world space coincided with the screen, right? So this is just like a notion to help you put them somewhere, but you never actually need it, right? It's not required for anything. It's just a thought experiment. The other way you could think of it is just always pick one to use. So always use world space, and then just think about these other things as being represented directly in world space. So I'm just going to say that the screen is here in world space. And that's sort of how we do it by intuition when we were writing it. That's sort of what we were thinking of, right? Here's where the camera is in world space, right? And that's fine, because we only need, at the end of the day, like I said, it all boils down to just a relative thing anyway after you plug through this. It's all relative, so you don't really care who's represented in what space. As long as you can get from one to the other, you're fine. Why are... oh, I should probably... There's a couple questions. I want to answer that one, but... a few streams ago, you said you preferred to call functions through a macro and then forgot to explain why. Oh, well, we haven't gotten there yet. I know which one you're thinking of. At least I think I know which one you're thinking of. Are you thinking of this one? Handmade.h push size. Are you thinking of this guy? It's not that I didn't forget to explain why. It's that I was intentionally saying wait till later. It's coming. Let's put it that way. It will happen eventually. Why is the familiar moving left to right, or did I miss something? I think that's probably just bugs in our... Like, we will clean that up in the render. I think that's just a bug in that stupid Z-fudge thing I hacked in there that was just... We were playing around. I suspect that's probably just a messed up thing in our Z-fudge. So as we're doing the render, I think that will get cleaned up. Why are computer coordinates upside down? I guess I don't want to say that I know definitively why they're upside down, but I mean, here's why I always think of them as why I think they're upside down. It's because, in the old days, the way that things worked was you had a cathode ray tube. And the cathode ray tube is basically, it's got like this, this is before LCDs, right? You don't see these around anymore. Almost no one makes them. But old arcade cabinets would have them in them there, for example. So here's your TV set, right? That you're watching, right? Here's like the dude drooling with big eyeballs. Sitting on some kind of a chair. Right? He's watching the television. Now, the cathode ray tube, the way that works is there's like this screen, right? This glass screen, and it's coated with phosphorus, right? So basically there's like this sort of glass, this piece of glass that's coated with phosphorus, and what the phosphorus is it's little R, G, and B like phosphorus coatings that when they are excited, when they get hit by, when they're basically given some sort of electromagnetic charge there, they give off color. There's an R1, a G1, and a B1. And so this cathode ray tube, what it does is it's basically, I don't even really know how they work. I believe it's magnetic. Basically what it can do is it can kind of shoot that beam of energy at one of these at a time, but it's just a beam. And so what it would do is it would shoot it, and it would just scan. It would go across, right? And so the magnets would just be set to like to aim this thing across, almost like, you know, like a sprinkler system or a laser fluid or something. It would scan across, lighting up the phosphorus, and they would modulate the intensity of that beam to change how bright each of the things was on the screen, right? And really, I shouldn't have introduced RGB yet, because in the old days it was actually just black and white. So really, there'd just be some phosphorus, but they eventually did RGB. It would then, when it got to the end, it would trace back and come here, right? And it wouldn't actually shoot any energy in that phase because it didn't want to light up anything there. And then it would start again, lighting up the next row. And for reasons that I do not know, you would have to ask an old TV engineering kind of guy. They always started in the upper left, scanned to the right, jumped back, and then started in the left again and scanned to the right and down, right? And that's how it worked. So when computer graphics came along, it was not connecting to an LCD, it was connecting to one of these, right? So what you had to do was you had to drive the signal of what intensity you wanted to send out the cathode ray tube for each point. Now, the easiest way to do that is to just have memory in the computer, right? The memory in the computer says what the intensity should be. What that means is the memory, right, is getting read out in that order as you go. So the easiest thing to do was just to say like, oh, okay, I'm pointing the first value in this memory is going to be that first pixel, right? So it just kind of is natural to say, well, okay, in that case, the way we store things is we store this pixel first, then this pixel second, this pixel third, right? And we get to the end, we store the next one, which means that if I was talking about a pointer to that thing, Y will always be talking about going up to, as I go up in Y, I'm going down where it would be on the screen, right? And as I go up in X, I'm going, you know, from left to right. And so, you know, I feel like, and I can't say for sure, but I feel like really that's why it started that way. If CRTs had gone the other direction, I feel like we would have had that wouldn't have been the notion, right? So I don't know. That's just my guess. I don't know for sure, but that's my guess. How important is it to know how to make a game engine versus simply using one? And if you were to use DirectX libraries, how much would the code differ? Well, DirectX is really more of a hardware interface kind of a thing. So the code for our stuff wouldn't differ much at all. The only thing is we're doing a little bit of software rendering stuff. That'd be the only part that wouldn't be there. But you'll see me use like OpenGL or something later on. I'll be showing how to do that, and then you'll be able to see exactly that difference. You'll be able to see the difference between the OpenGL path and the software rendering path. You'll be able to look at those directly. So we'll be covering that. But in terms of how important it is to know how to make a game engine versus simply using one, the answer is it depends how much you care about quality, B, how much you care about differentiation, and C, how much you care about exploring new things, right? So let's start with quality. One, I think that people who don't know how to build a game engine, when they go to use a game engine, often produce lower quality results. And the reason for that is because they don't know everything that's going on and they don't super understand how the game engine works. So they aren't able to drive the quality level to where it should be when they use an engine, because they really just don't have the depth of understanding of what the engine's doing to be able to handle situations that they want to be able to handle properly. And I see this a lot in games when I'll play them, you know, like I'll play a game that was written in Unity or something, and there's a bunch of stuff that's busted, and I know that it isn't Unity that's busted. I mean, you could argue whether it's Unity that's busted or not, but I know that I could have gone and fixed Unity, that problem in Unity, let's say, because it wasn't a thing that Unity forced you to do. It was just how they were choosing to use it. But they didn't know any better, right? Because they didn't understand how Unity works at a deeper level, and they didn't understand what they would have to do to fix the problem, right? And so I feel like if you care about quality as a game developer, you really kind of have to know a lot about how engines work, because you're never going to actually be able to get high quality results out of an engine without knowing a lot of that stuff. And some people disagree with that, and oftentimes the games that they point to I think are low quality in a number of areas. That doesn't mean the game's bad. The game might be fantastic. In fact, there are games that are absolutely fantastic that are written in like Flash or whatever, with very little knowledge of how things work. The game might be great, but there's tons of stuff that was low quality in there simply because it couldn't go to that level. So quality and how good a game is aren't related. It's sort of like saying, how do you like this TV show? And talking about whether it was whether the camera work was really good, right? There's lots of quality axes, and some of them have nothing to do with how much you know about engine design, but some of them have a lot to do with it, right? And so I feel like if you care about quality a lot and you want to be sure that you can always do whatever you need to do to make sure that your game, whatever it is, doesn't have any of those rough spots, because you can go in and fix them and do what you need to do. I think that's a really compelling reason to know engine stuff. It doesn't mean you shouldn't use an engine. It may be that it's a very good decision to go use an engine. You should use Unity, you should use Unreal 4 or whatever. Like, that may be true. For the game that you're making, you might really want to use one because it'll save you a ton of time and it does the things you need to do. But you want to still know how it worked. You want to be able to modify it well. You want to be able to understand why it is breaking when it is breaking, or why it is slow when it is slow, and fix it. That's really important for achieving a high quality result in games. And so that's the first thing. And you have to decide how important that is to you. You may not care about that. You may be like, low quality is fine. I'm all about this other aspects of game design, and I don't care about the quality. If it looks lousy, or if it's slow or stuttery, or there's a loading screen that's 30 minutes long, I don't care about that. It's not what I'm about. That's cool too. But I'm just pointing it out that if you care about those things and you want to do all those things efficiently, engines are not fire and forget these days, unfortunately. There's actually just a lot of stuff you have to know to be able to use them effectively. They're a complicated tool that requires a lot of knowledge to use effectively. And so understanding how an engine works is part of gaining that knowledge. Okay. So thing two, again, sort of depending on differentiation. So if you know how to write a game engine, even if you choose to use an engine, because you can write one, you have the ability to mod that engine to do things nobody else can do, right? Or rather, no other person who doesn't know how to make a game engine could do. So it's very easy to differentiate yourself and your game if you have those skills, because you can do things that other people who all they can do, all they know how to do is like click checkboxes or whatever, could never do, right? They're never going to be able to do a bunch of things that you can do if you knew how an engine worked, right? That's pretty straightforward and self-explanatory. So if you don't care about that, if you're like, nope, I just make games where you kind of just walk around a 3D space and that's what Unreal and Unity do, so we're good, then you're probably fine. But if you have specific things you might want to do that involve a little more deeper stuff, maybe like advanced time manipulation things or stuff like that, right? People who can do that, they can make that game, and you can't, because there's no options for that in Unity or Unreal. That doesn't have that particular way that you wanted to warp time or have it do something, right? So that's it, right? You can't do it, and they can. And then the third reason is, in addition to the differentiation, is exploring things that people haven't done before, right? So there's tons of things that the Unreal Engine 4 and Unity can't do. They are a set of things that we have not even conceived of yet, potentially. And then there's a set of them that we have conceived of and that they just don't do, right? If your game wants to be in one of those spaces, you can't use those engines. Or you can't use those engines without heavily modifying them. And if you don't understand how to make a game engine, you can't do that. So again, you can't really ever make those games. And so in some sense, you could think of it as, if you don't know how to make a game engine, you will only ever be somebody who can make games in the small space of games that we currently have carved out by those engines. Everything else, you will have to wait for other people to make for you, And you will have to hope that they license whatever they make, because you can never get out to that space because the engines don't do it, right? So taken together, I just feel like if you are a game developer, it's incredibly limiting to not know how to make an engine. Especially in this day and age when games haven't really defined all that they could be. Like, we don't know every possible way a game can be yet. Like, we're still coming up with new ways that games can be. We're coming up with new genres even. Like, there's a lot of progress in terms of defining what a game is. Not being able to be a part of that because you just don't know how is very, very limiting. And it doesn't mean that you can't still make good games that are interesting in the known space of games, but it does mean that you're not on the frontier. And personally, I feel like the frontier is a way better place to be than just kind of with everyone else in the known space. So hopefully that's a pretty complete answer. No more questions? Ask me no more questions. I will tell you no more lies, as they say. All right. Well, if there's no more questions, there's no more Handmade Hero. All right. Well, thank you everyone for joining me for another episode of Handmade Hero, where we almost got through bases. We will try to do that tomorrow so that we can have our sort of rotation and scaling in there. Now, of course, we'll have to actually start working on the rendering to do rotation and scaling as well, so that'll be a whole nother issue. But just in terms of getting our stuff defined more cleanly, we kind of have to work through this stuff. So hopefully that will go smoothly tomorrow, and I can do a little more whiteboard diagramming, then we can implement it. And that will set us up for kind of some nice, I feel like by Friday I'd like to have it so that the specification of stuff is a little cleaner and it's not so weird about like when things are getting negated and meters to pixels and that sort of stuff. So that's what I would like to do, and that's what we'll continue doing tomorrow. So anyway, thank you very much for joining me. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. You can use the little pre-order button. It comes with the source code, so you'll be able to download it every night and follow along and just play around with the stuff that we've been playing around with, which is fun and hopefully educational as well. We also have forums where you can ask questions. If you go to that site, there's also things like ports to Mac and Linux. There's even a BitTorrent now where you can download high-res versions of the videos so that you can watch them without using YouTube. That's kind of handy. There's a bunch of stuff on there. Go check it out. It's cool. We have a Patreon. If you want to support the video series, you could subscribe to that. We have a tweet bot that tweets the schedule if you want to know when we're going to be live. So that's pretty handy. And of course, we have an episode archive. You can get to the YouTube one here, and there's also an episode archive that's annotated out in the forum, so check that out as well. So yes, I hope that you have. Hope that you will have a lovely April Fool's Day tomorrow. I know that the internet will be rife with April Foolings, so hopefully that will be good, and hopefully no one plays a prank on you. I know that I am certainly hoping no one play a prank on me, and so we will see. Hopefully, we will all sort of come away unscathed from the sort of the tomfoolery, if you will, the April tomfoolery. So thanks everyone for watching, and I'll see you tomorrow.